This one's a bit of a challenge problem. We're in some of the harder ACT stuff right now, so I want you to, if you don't understand what I'm doing, remember that this is building on a lot of skills that you have previously. The first thing we need to do is notice that it says one of the solutions is -1. And we have a cubic function here, which ordinarily is very hard to factor. You need to do what's called synthetic division, or you could also do long division. I'm not going to do both. I'm going to pick synthetic division simply because it's faster. So I set up my synthetic division bar. Hopefully you've seen this before. This is going to be 1, -8, 11, and 20. Notice where those are coming from. Those are the coefficients in here. And I take my other solution, -1, and now I work through the standard procedure of synthetic division. Okay, that's really good news. We got a 0 right there. Okay, that means, well, we expect a 0 because it told us that the solution was -1. If I got something that was not 0, I would have been wrong. So what this means is when you reduce this or factor out the x equals -1, as I did right here, x equals -1 produces a factor of x plus 1. When you factor that out, what's left is x squared minus 9x plus 20. Okay, that's my polynomial. That's that cubic thing that we started with. And the question is, can we factor this more? Well, sometimes you can and sometimes you can't. Okay, let's see. I know how to factor this. I can do this one in my head. This is fairly quick. I get the following: x minus 5 and x minus 4 for that quadratic part. Now, if you look at this, this gives me two possibilities. I get x equals 5 and x equals 4. So now I have three solutions here, one being the -1 that I started with, two of them being right here. And if I look over this list, are both negative numbers? No, that's not it. One's negative, one's positive? Nope. Both are positive real numbers. There we go. Okay, both are positive real numbers. That's the solution to this problem. Now I'll tell you which one of these choices is completely bogus and can never work, regardless of what you're looking at. One is real and the other is complex. See that one? You're never going to get something like that because we're dealing with a real polynomial. And a real polynomial might have two complex roots if you can't factor it. It might have two real roots if you can factor it like we did here. But it'll never have one real, one complex. That's not possible when you have a real polynomial.